So this matrices is almost done. Not very long, is it? So for a 3 by 3, I might rearrange these already by putting this one in first, second, and third, just so that I have already a 1 in the top. And 4, 1, 1, 5. So again, our goal is to get basically, there'll be numbers here in the end, and an identity matrix over here. Now, as far as ordering things, just like we did with the Gaussian elimination, we got these zeros first. Then we get this 0 second. So you get your bottom left-hand corner of zeros first. Then once you've got this bottom row with 0, 0, and then there might be a number there, you can just divide that whole equation by that number to get a 1 there for your third thing. Then working your way up to get the top right-hand corner is sort of the same idea as getting bottom left-hand corner. We're going to get these zeros next, followed by that 0. And then it won't be hard to make those ones 1 in the end either. So let's do this one together. I'm not going to change my row 1, so I'll rewrite it. I want to get these zeros first. So I'm going to have to change row 2. Can you see that if you took row 2 and subtracted 2 row 1s, that would get you a 0 there? If we did that further, we would get a 3 here. 2 plus 2 would be 4 here. 10 minus 4 would be 6. And if I wanted to get a 0 in the bottom left-hand corner, then I would have to change row 3 to equal row 3 minus 4 row 1s. So I got a 0 there. 1 minus a negative 8 will give me 9. This will give me 4 plus 1, 5. Negative 8 plus 5, negative 3. My next goal is to keep rows 2 and 3 the same, but get this 0 here. So I'm going to take row 3 and make it equal to row 3 minus 3 row 2s. Because the 0 minus 0 will still give me the 0 in the bottom left-hand corner. Now 9 minus 9 will be 0 here. And 5 minus 12 will be negative 7. And negative 3 minus 18 will give us negative 21. So in reduced echelon form, we're done. And we can now substitute in and work our way back to find everything. But for reduced row echelon form, we're going to want to get this to the identity matrix. We now can take row 3.
Excuse the interruption, Mr. Kaki. Please contact the office, please. Mr. Kaki, please contact the office.
Divided by negative 7. And we get that z is equal to 3. We are done with row 3, so that one's not going to change. Now, our next goal is to get both of these to be zeros. So we're going to change row 2 and row 1, and we're going to need row 3 to do that. The nice thing about row 3 is now that there's only a 1 where the z is, substituting it back in isn't going to change anything else. So when we look at row 2, we're going to need to have it row 2 minus 4 row 3s. Well, timesing these ones is not going to change these values because those ones are zeros. We're going to get a 0 there, and then we're going to get 6 minus 12, negative 6 there. And row 1, in order to get a 0 in the top right-hand corner, we're going to just have to take row 1 and add it. Add row 3 to it. So again, these ones are not going to change. And then when I add these together, I'm going to get 5 up there. We can now take row 2 and divide it by 3. Row 3 is not going to change. Row 1's not going to change, and now row 2 will be 0, 1, 0, negative 2. All we have left to do is get this one in the middle to be 0. We're going to take row 1 and add 2 row 2's to it. This will still be 1. This will still be 0. This will be 1, 0, 1, 0, negative 2. And so x is equal to 1, y is equal to negative 2, and z is equal to 3. Now if we take out our calculators, and we're going to type this same matrix that we started into our calculator. Second matrix, over to edit, 3 by 4, and we had 1, negative 2, negative 1, 2, 2, negative 1, 2, 10, 4, 1, 1, 5. And now under matrices, go over to math, go down until you get to reduced row echelon form, and pick matrix A. Is that the same answer we got? Good. So one thing that I would do as far as checking, let's say you're practicing some of these questions and all of a sudden you're getting into fractions and you're feeling like I might have done something wrong or my numbers don't feel like they're working out nicely, and instead of continuing to work with those fractions and getting further and further behind, you could type it into your calculator and find out what the answers are supposed to be. So here we know that x is supposed to be 1, y is supposed to be negative 2, and z is supposed to be 3. Then what you can do is you can go to a place in your equation. Let's say I'm unsure that this is right, just as an example. What I could do is I could say, well, I know x is 1, y is negative 2, and z is 3. If I put negative 2 in for y, can you see that this would be negative 6? And 3 for z, this would be 12. Is negative 6 plus 12 equal to 6? Yes, so then I would know, okay, I know that that line is right. That's not where my mistake is. If I'm trying to find where I made my mistake, that's a good way to check. And you could work your way back until you find out where you made the arithmetic error. Yes? So did most of you, I'm looking around, and most of you decided to put the 1, -4, -2, 12 as the first one? Okay. Did most of you then put the 2, 4, -3, 9 next? No? How many? Most people go 3, 4, 1, -1 next? So some people put the second, flip those second and third. Okay, it won't matter. You'll get, the situation that arises in this question is going to happen no matter which way you put these equations. So we'll go 3, I did that one already, that's a 2, perfect. 4, -3, 9. So we're going to start by getting those zeros there. That's going to be no problem. Row 2 is going to equal row 2 minus 3 row 1s, and row 3 is going to equal row 3 minus 2 row 1s. And so row 1's not going to change. And we're going to get 0 there. We're going to get 4 plus 12, 7, -37. And here we're going to get 0. We're going to get, this one minus 2 would be 12, 1, -24 plus 9, -15. Okay, so here is where we run into a bit of an issue. We've got a 12 and a 16. They're not very nice. If we try to make any of them smaller by dividing, we're going to deal with fractions. Like you could divide 16 by 16, but then you'll have 7/16 and -37/16 as a possibility. Okay? So what I'm going to try and do right now is I'm just going to try and get these numbers here to be the same. Sort of like a lowest common multiple. Between 12 and 16, 48. So I'm going to take row 2 and make it 3 times row 2. That'll get me 48. And row 3 and make it 4 times row 3. My numbers are going to get bigger for a little bit, but at least they'll both be 48s there, and it's going to be pretty easy to figure out how to make one of those go away. Again, row 1 didn't change. Timesing this one by 3, 111. And this one by 4, and now we can get that 0 quite easily. By just subtraction. So 4 minus -17 and -111 minus -51. Oh, no, sorry, +51. -60 minus 111 will be +51. And now I can take row 3 and divide it by -17. Now, if you wanted to, you could take row 2 and divide it by 3 again, to get back to those smaller numbers, because we multiplied it here by 3. We took row 2 and multiplied it by 3 so that it would be easier for us to cancel out. If we wanted to revert back to what we had with the 16.7 and negative 37, we could do that. And that might make it a little bit smaller numbers going forward. So I'm going to just erase these over top here and revert that back to 16.7 and negative 37 that we had before. You could show that as another operation if you wanted to. Row 2 is row 2 divided by 3. Yes? And then do the multiplication within the operation, you could. Just the problem with doing too many operations is that it increases your chances of a mental math mistake, and then that can lead to mental math madness. So we don't want any M&M's in here. So now we could just take row 2 and minus 7 row 3's. So that'll make this one 0, and negative 37 minus 21. Oh, plus 21, right? Plus 21 will give negative 16, which is a pretty number considering we have a 16 already in the middle. So now you could divide that row by 16. Oh, I guess I could have done my operation earlier for changing row 1. Row 1, let's get this 0 where the negative 2 is first. Add 2 row 3's to it. That'll give us a 0 there. And these ones won't change. And 2 times negative 3, that'll make this 6. And finally, row 1 plus 4 row 2's. We'll make this 2. Yay! Now, if these weren't nasty to begin with, for the amount of stuff you have to fill your page with, we could make a word problem. And that word problem would make you figure out 3 equations with 3 unknowns, and then you could solve that using matrices. Or we could, that's true. We could also skip it. But here, let's just see if we can create the 3 equations. Total number of moons? 43. So S plus U plus N. Are you okay with those variables? So the total number of moons around Saturn and Neptune is 9 more than the number of moons around Uranus. So how are we going to write an equation for that sentence? Saturn plus Neptune is somehow related to how many are around Uranus. It's 9 more. Where am I going to put the plus 9? Okay. Sorry? S plus n minus u equals 9. Okay with that? And Saturn has 2 more moons. And I guess this is where we'll end. So you can make the one more equation and then solve it.